We continue with problem number 4. This is division of two functions. So we're going to have number 4 is f of x equals to 4x plus 1 and g of x is equals to 3x minus 2. Find f over g. F over g of x. In the previous example, 3 examples, I forgot to tell you about the domain, but this is, as we have been doing this in class, the domain in the previous 3 problems were all real numbers, because we don't have any restriction in that, in those 3. So number 4 is f over g of x, means f of x over g of x. F of x is 4x plus 1, g of x is 3x minus 2. Then in this kind of problem, we always try to factor numerator and denominator and get rid of common factors. However, this is not factorable. None of them is factorable, so that's basically the answer of the problem. Since they're asking us to state the domain as well, so the only restriction we're going to have in this function is the denominator cannot be equal to 0. So in order to find what that's going to happen, we have to just find the domain here. We're going to do this. Go 3x minus 2 equals to 0 to find out what value for x is going to make this expression equals to 0. So we're going to add 3, sorry, we're going to add 2 in both parts. And we have 3x equals to 2, and then divide by 3. And that's telling me that x is equal to 2/3. When x is 2/3, the denominator becomes 0. So the domain is going to be then all real numbers except x equals to 2/3. And that's the answer of the problem. Problem number 5 is another division. F of x is equals to a square root of x, and g of x is equals to 4x minus 7. And we're finding f over g as well. F over g is f of x over g of x. F of x is the square root of x. G of x is 4x minus 7. Okay, so in this case, the intersection of these two domains, because the domain of the division, the domain of all these functions, is the domain for both of them, that works for both of them. In other words, the domain for both of them, the one is overlapping the domain in common. So in this case, the domain of the top one is all real numbers that are greater than or equal to 0. The domain of g of f is x greater than or equals to 0. The domain of g, since it is in the denominator, we cannot accept the value when the denominator becomes 0. Following the same procedure here, I have to do 4x minus 7 equals to 0. We add 7 in both parts, and we have 4x equals to 7. Then divide by 4, x equals 7/4. That's a value that we don't want. So the denominator is everything except when x equals to 7/4, and the top one is only positives, including 0. So the domain for f over g is equals to x greater than or equals to 0, but at the same time we don't want x to be 7/4. Okay, so all the values greater than or including the 0, it's okay to have 0 in the denominator, because 4 times 0 is 0, minus 7 is negative 7, so 0 is fine. But we don't want 7/4, which it is in the set because it's positive. So we need to exclude that value from the set. So that's the domain for the whole function, f over g.